Good morning. This is work that notes for Tuesday, May the 5th. Happy Cinco de Mayo Day. It's also my transplant anniversary day. So we're going to be celebrating today on Tuesday. So um, on Monday, we talked about similar figures. Today, we're talking about indirect measurement. So we're going to be kind of doing the same thing as we're going to be finding a missing number. We're going to ask you for a number, and we're going to have to use this proportion and similar figures idea in order to take indirect measurements. So as we work forward, this is the second part of 8-0 lesson. I will have something different for you to do tomorrow on Wednesday, May the 6th. So, but let's look at indirect measurements today. So again, we talked about in our similar figures that we had to follow two rules. One, that the corresponding angles had to be equal, and number two, the lengths of the corresponding sides are proportional. We looked at that at the beginning of our lesson yesterday. So as we move forward, we're talking about indirect measurement, which means kind of we're going to use similar figures to compute distances that are difficult to measure directly. So if we look at a person that is 5 feet tall that casts a shadow of 4 feet, and you're standing next to a tree, and we can somewhat measure how long the shadow of the tree casts, which is going to be similar. It can be proportional to our own shadow. We want to find out how tall that tree is. I'm not going to be able to climb that tree and measure how tall the tree is, so I'm going to use the shadow and my own height and my own shadow length to figure out how tall that tree is. So we're just going to put this together again. Here's the height of the tree. It's an unknown, so we can put any variable in there that we want. And again, we know that the person is 5 feet tall. We know they cast a 4-foot shadow. We know the tree casts a 10-foot shadow. So as we look at putting these together, we know that 5 feet goes with our unknown, and we know that 4 feet goes with 10 feet. So as we look at this, so if we put 5 over x, we're going to use x for our question mark here for the height of the tree. That's going to equal 4 over 10. Okay, so as we look at those two things, sorry, my handwriting is terrible this morning. So let's just make sure that we cross multiply. So we get 4x equals 5 times 10 is going to be 50. We're going to divide each side by 4. So 50 divided by 4 is 12.5. Again, we're talking about feet, so we're going to label feet. So that tree is going to be 12.5 feet tall. Okay? So hopefully that this is not a difficult concept. It's just one of those things that you kind of see out in the real world. We're not dealing with exacts here. So as we look at this, again, as we go through to the next page, write a proportion to solve the problem, draw a picture to help set it up. A building that is 70 feet high casts a shadow that is 150 feet long. So here's the shadow that a 70-foot building casts. If a nearby flagpole casts a shadow of 60 feet, how tall is the flagpole? Again, we're gonna struggle at taking heights at taking measurements in anything over our height feet. So anything over 6 foot, I'm going to struggle with. So I'm going to use what I know, which is going to be its shadow that it casts. Okay, so we're just going to set a proportion the same way. So we have 70 over m. Okay. Let's make sure we get our sides lined up correctly. So we have 150 and 60. So 150 over 60. So if we put 70 over m, we have to make sure that 150 is over 60. So let's make sure that we're putting the right numbers in the right place. And once we do that, we know what we're doing as far as solving that. We get 150 m is going to be equal to 4,200. That's what 70 times 60 is. We're going to divide by 150. We get that. So m is going to be equal to 28 feet. And that's our answer. So our flagpole is 28 feet high. So And that is going to be a similar figure to the building because it's all proportional. Okay, so let's move on to our next slide. In the figure at to the right here, we look at triangle DBA, which is DBA, and it's marked in red, is similar to triangle ECA. So this is the big triangle. So we have a triangle, smaller triangle inside of a larger triangle. So Ramon wants to know the distance across the lake. So a hint would be look at the big triangle and the small triangle inside of it. So you always want to look for these. And again, we're labeling triangles by using their points. So we look at these two things. So as we set up our proportions, okay, what we're looking for is we're looking for that. Okay, that's our missing. Okay, so if we see the little lake in here, okay, can everybody see that? It's in blue. So D would be equal to the length of our the distance across that lake. So that's what we want to find. That's what it's asking for. Ramon wants to know the distance across the lake. Okay, so as we set this up, so we're going to set up D is going to be similar to 40. So we're going to set up 40 meters over our unknown. Okay, so if I use this side of this triangle, then I have to use what side? I have to use the side of this triangle, which is 320. That's right there. And then I have to use this long side of the big triangle, which is there to there. And that's going to be 320 plus 62. 162. Okay, to get that big, long side right there. Okay, and that we get 482. Okay, hopefully that makes sense. So as we set this up, we know we cross multiply from here. So we get 320. D is going to be equal to 19,280. We're going to divide by 320. So we get that. Divide that by 320. So across the lake, we're looking for D is going to be 60.25, and that is meters. So the distance across the lake is 60.25 meters. So hopefully that's not too difficult. You just got to look at the picture, give yourselves time to figure it out. Don't be in a rush, and just work through the proportions. So make sure if you have any questions that you're emailing me. As we go forward, you look at your homework. It's going to be sheet 8-0B. So make sure that you can insert your text boxes, show as much work as you can so I can see if you really know what you're doing, or if you don't. So make sure that you're just not pulling answers off the computer somewhere, but you're actually trying to figure it out. So make sure that you're showing as much work as you can. That will help me out to know if you really understand what you're doing or if you need help. So make sure you're emailing if you need help. So I hope you have a great day. Happy Cinco de Mayo. And I hope you have a great rest of the week. So I miss you guys. Have a great rest of the week.